Alright, so here we are with our 5-3 assignment using those identities that we just talked about of adding angles and subtracting them. So first thing that we're going to do is sine of 15. So all we need to do is go to our unit circle and identify which of these can make 15. So I feel like we did this one in the notes, but either way, so fun. So let's do 45 minus 30, since that is 15. Alright, so we're going to change this to sine of 45 minus 30. And so that means that we're going to use our formula of sine minus. And so we're going to get sine of the first thing times cosine minus cosine of the first thing times sine. So here we are, sine of 45. And then cosine of 30. And that's going to be added to cosine of 45 times sine of 30. And sorry, that's supposed to be minus. Okay. So now we need to evaluate sine of 45. Sine of 45 is right there in the middle, so it's square root of 2 over 2. And then cosine of 30 is that first piece. And so the cosine, or the x value to get there, is going to be 1 over 2. Wait, it's 30, so square root of 3 over 2. Then to that we're going to take cosine of 45, and so cosine of 45 is the same as sine of 45. And then that's going to be multiplied by sine of 30, and sine of 30 is a half. So if we put all of those together, let's see, the first piece is going to be square root of 6 over 2. And then, of course, they're both over 2, so the next one is going to be square root of 2. And that's our answer. And again, they don't want you to necessarily simplify from there. That is just it. Oh, and those are both 4. Hi. 2 times 2 is 4, and 2 times 2 is 4, so this should be 4 on the bottom. Doing well. Okay. So we've got tangent of 15. Of course, tangent uses that kind of scary looking formula. So I'm still going to use 45 minus 30, but of course we're using that other formula. So taking a look at this one here. And so we're going to have tangent of 45 minus tangent of 30, and then tangent of 45 times tangent of 30 with a plus. So we've got tangent of 45 on top minus tangent of 30, and then that's going to be all over 1 plus tangent of 45 times tangent of 30. So tangent of 45 and tangent of 30, here we go, tangent of 45 is going to equal 1, and tangent of 30 is going to equal sine over cosine, so a half over square root of 3, so 1 over the square root of 3. So let's see, tangent of 45 is 1, and then we've got 1 over the square root of 3 for tangent of 30, and then 1 plus 1, but that's times 1 over square root of 3. So it doesn't really simplify very nicely, so we'll just have 1 minus this 1 over square root of 3, and then 1 plus 1 over square root of 3. And again, we could rationalize that, but it doesn't necessarily change the answer very much. Alright, then we've got sine of 75, so we're either going to find 2 things to add to be 75, or 2 things to subtract to be 75. So looking over here, I mean, I personally like adding, so I'm just going to add 30 and 45. So it's going to be sine of 30 plus 45. And so we're going to go to our formula with sine, and we're going to use this one. So we've got sine of the first one times cosine of the second angle plus cosine of the first angle times sine of the second angle. So let's see, the first one I said is 30. So sine of 30 times cosine of 45 plus cosine of 30 times sine of 45. Alright, so let's see, sine of 30, we've already done it over here, is a half. Cosine of 45, again, over here is square root of 2 over 2. And to that we're going to add cosine of 30, which is square root of 3 over 2. Again, I'm just referencing this problem over here. And then sine of 45, which was square root of 2 over 2. So this one's simplified now with the common denominator of 4, because I'm not going to forget that, is square root of 2 plus the square root of 6 over 4. Alright, continuing on, we're going to do cosine of 75. So I'm again going to make this cosine of 30 plus 45. And so now I just need to fill in our formula of cosines being added. So cosines being added here is going to be cosine of 30 times cosine of 45, and to that we're going to subtract sine of 30 times sine of 45. Alright, so cosine of 30, again referencing the problem above, is square root of 3 over 2. Cosine of 45 is going to be square root of 2 over 2. And to that we'll be subtracting sine of 30, which was a half, and sine of 40, which was square root of 2 over 2. Combine all those pieces together, we get square root of 6 over 4 minus square root of 2 over 4. Alright, next one I'm going to change from pi over 12 to its degree measure. So just for reference, pi over 12 times 180 over pi means that our degree measure is actually 15. So cosine of 15, of course, I'm going to use 45 and 30 again, so kind of a lot of the same thing, but cosine of 45 minus 30. Alright, so moving on to cosine that is subtracting, so that's this one here, means that we will have cosine of 45 times cosine of 30 plus sine of 45 times sine of 30. So cosine of 45, one more time, is square root of 2 over 2. Cosine of 30 is square root of 3 over 2. Sine of 45 is square root of 2 over 2. And sine of 30 is a half. So we're going to get square root of 6 over 4 plus the square root of 2 over 4. So it looks like sine of 75 is the same as cosine of 15. Alright, so next one, again, I'm going to convert this into degrees. So 7 pi over 12 times 180 over pi means we get, let's see, 105 degrees. Alright, so let's see. I like addition, so I'm going to do sine of 45 plus 60. So going to our sine equation of addition, we're going to have sine of u, so 45, times cosine of 60, and then that's going to add with cosine of 45 times sine of 60. So you kind of switch which one is in there. So let's see, sine of 45 is square root of 2 over 2. Cosine of 60, we haven't really come across much yet. So cosine of 60 is the x value, is a half. And then cosine of 45 is square root of 2 over 2, and sine of 60 was square root of 3 over 2. So putting all those together, square root of 2 plus square root of, is that a 2? Yeah. 6 over 4. Alright, and now we'll do tangent, which of course changes everything up, but 5 pi over 12 can be converted. So we'll have 75 degrees instead. And again, I'll make that 35 plus 40. Wait, 30 plus 45. Alright, so we're going to be adding tangents. So again, taking a look at our formulas, we've now basically used all of them. We're going to add u and v. So, tangent of 30 plus tangent of 45 is going to be over 1 minus the tangent of 30, and that multiplied by the tangent of 45. So we need the tangent of 30, and so the tangent of 30 is 1 over 3, and the tangent of 45, square root of 3, and the tangent of 45 is 1. So filling in our pieces here, tangent of 30, we said was 1 over the square root of 3. Add that to tangent of 45, which is 1, all over 1 minus tangent of 30 again, which is 1 over the square root of 3 times 1, which I'm not really going to put in there. Alright. So hopefully that made sense. Now we just get to look at them and work backwards. So again, anytime that you have sine and cosine together, like we see here, that is going to end up being cosine of something combined together. So this is going to be cosine of 94 and 18. But then we just want to double check anytime that you have addition here in cosines. So again, cosine had addition between them of sines and cosines. It's actually got negative then. So we're going to do cosine minus 94 and 18. So we actually have cosine of 94 minus 18, 76. Alright, so the next one, the next two actually have sines and cosines separated, and so that's where we know that it's going to be sine of something with pi over 5 and pi over 2. Or in this one, sine of pi over 3 and pi over 7. So if we take a closer look, anytime that it's sine and it's got a plus between the two separating pieces, you're going to have plus, versus if there's minus, it's going to be minus. So cosines are opposites, but sines are the same. So plus here, because of the plus that's there, and minus here because of the minus that's there. And so putting those together, let's see, this would actually be a common denominator of 10. And so we'd actually have sine of 2 pi's plus 5 pi's, so 7 pi's over 10. And then over here, we'd get 21 as our common denominator. And so we'd have sine of 7 pi's minus 3 pi's, so 4 pi's over 21. Alright, and then the last one, trying to put it together as one tangent. You've got a plus sign on top and a minus sign on bottom. So looking at our tangents, a plus sign on top and a minus sign on bottom means that we're adding the two pieces for tangent. So tangent of 19 plus 47. So 66. All right, so the next ones here are proving, and so this is going to be using the unit circle potentially to just kind of show that, hey, these two things can come together. And we did do a few of these in the notes as well, so there's 6 over here and then 2 more. So let's go through our formula. We've got sine, and remember that sine was the one where you have kind of every other. So we're going to have sine of the first one times cosine of the second one. And then since it's minus and it's sine, we're going to keep the minus. And then it's cosine of that first one and sine of that second one. And so now we can evaluate this with the unit circle. So we'll of course keep sine, but then cosine of pi over 2 is going to be 0 and sine is going to be 1. So cosine is 0 and sine is 1. So sine times 0 is going to cancel, and so we're just left with negative cosine. And that's what we wanted to have on the other side. Alright, the next one is tangent. So tangent of a subtraction going on. So looking at our formulas, tangent of subtraction means the tangent subtracting them, and then 1 plus. So tangents subtracted on top. And then on bottom, 1 plus the tangents multiplied. So then we need tangent of pi over 2, and remember that that's sine of pi over 2 over cosine of pi over 2. And so we just did sine of pi over 2 and cosine of pi over 2 in the previous problem. And sine resulted in 1 and cosine resulted in 0. So this is actually when we go back to the notes, which actually told us, other than one piece, was that if you happen to have tangent of course, one second, is the same as sine over cosine. And so because of that, if we take it that way, we can then be doing sine of u minus v over cosine of u minus v and evaluate it that way. From the previous problem, sine of x minus square root of 2 is already negative cosine. We already saw that in the previous one. So our numerator becomes negative cosine of x. And then we can use our previous idea because we're doing x minus pi over 2. So if we scroll back to here, we can kind of use this idea here of cosine of pi over 2 minus degree measure is sine of theta. Or in this case, x. And so in that case, negative cosine over sine is going to be negative cotangent. So kind of just another way, especially when you come across an undefined, to work it out that way. Again, tangent is always sine over cosine. It's just sometimes we don't do that. All right. So this next one, again, is one of our identities, but we're trying to prove that identity. We can kind of use it, if you want to kind of talk about how we got here to sine. So in that case, we're going to do cosine. And remember that cosines are the ones that have a cosine together and a sine, but then the opposite sign. So cosine of the first piece, cosine of the second piece, but then because this is subtraction, we have addition, and then sine of the first piece, and then sine of the second piece. Alright, so we need cosine of pi over 2, and cosine of pi over 2 is 0. So it's going to be cosine times 0, and then we've got sine of x, and then sine of pi over 2, which is 1. And so again, these will cancel because it's 0, and then we're left with sine. So again, if you didn't love the conversion before, we now have it down here. Alright, so, oh my, now we have 2 within 1, because we're going to be doing a cosine and a sine here for this piece, and then also for this one. So that's interesting. Alright. So the first thing we're going to do is identify this as the u and this as the v. And so we're doing u minus v for cosine. So u minus v for cosine means that the cosines are first, sines are second, and it's the opposite symbol. So instead of a minus, it's a plus. I'm going to need a little bit more room for this, so I'm going to start writing up here. So let's see, we're going to do cosine of u, which is going to be pi over 2 minus x, and then times cosine of y, and then to that we're going to add sine of u, which is pi over 2 minus x, times sine of y. And then this piece here, again, we just proved, well actually we have an identity for, so I'm going to do it that way. Cosine of pi over 2 minus x is sine. And then sine of pi over 2 minus x is cosine. And so with our first piece here, we're going to end up with sine of x, cosine y, and then to that we're going to be adding cosine of x and sine of y. And so this is interesting because now we're going to use one of our identities that we're just talking about to go backwards, because notice that we have a sine and a cosine, and then a cosine and a sine of those two values. And so this actually goes backwards now to using the sum and difference identity of sine. And of course there is addition here, and so that means that we're going to be doing sine of x plus y. So basically we use a sum and difference identity to expand it, and then use a sum and difference identity to compress it as well. Out and in. Super. Alright, so the next one we're going to use sine addition property. So we've got sine of the first one times cosine, oops, sorry, that's an x, of the second one. And then it's sine, so they're going to stay plus, and then now cosine of the first one, and then sine. So going over to our unit circle for pi over 6, that's 30 degrees. Sine is a half, and cosine is square root of 3 over 2. So we've got sine of x times square root of 3 over 2 plus cosine of x times a half. And of course that's what they have there. They've just put the number first and then the tangent or trig. Alright, moving on, let's see, we've got subtraction with cosine. So we're going to do cosine of the first piece times cosine of the second piece. And it's cosine, so now it's plus. And then sine of x, sine of pi over 4. Cosine and sine of pi over 4, it's over here, and they're the same. So we've got cosine of x times square root of 2 over 2 plus sine of x times square root of 2 over 2. And so we're going to take that square root of 2 over 2 out front. And so we have square root of 2 over 2, and then our leftovers of cosine x plus sine x. Alright, and then our last two here, we've got a tangent of addition. So via our formula, that means tangent of the first piece plus tangent of the second over 1 minus tangent of the first piece times tangent of the second. So tangent of pi over 4 is 1. And so this piece becomes 1, and this piece becomes 1. So we'll have tangent of theta plus 1 over 1 minus tangent of theta, which potentially could be multiplied by 1, but not really necessary. And then, of course, they rewrote it with the number first and then the trig. So addition is commutative, so we can put it first or second. Alright, and then our last one, cosine with addition, means that we've got cosine of the first piece, cosine of the second piece, and then cosine flips the sign, so minus sine of the first piece and sine of the second piece. So, hopefully remember from our previous problems, but cosine of pi over 2 is going to be, let's see, cosine is 0 and sine is 1. So it's cosine times 0 minus sine times 1. So ultimately this goes away and we're left with negative sine. Boom. Alright, that's it. So just manipulating and using our formulas. Alright, 5-3.